Thanks for coming and listening. I'm Jason Grout. I work here at Bloomberg for the last couple of years. Sylvain Corlay worked at Bloomberg, but he recently left Bloomberg to found his own company, QuantStack, but he still works with us here at Bloomberg. And we wanted to talk about a project that we serve on the leadership for and have been lucky enough to work with quite a bit in the last few years, and that is Project Jupyter. It's an open source project for doing tools for interactive and reproducible computing. So, quick poll. Can you raise your hand if you have heard of IPython or Jupyter? Oh, fantastic. My job has got a lot easier now. Have you used IPython or Jupyter? Oh, it's much easier now. Have you used the Jupyter Notebook? Okay. Quite popular. Have you used interactive widgets in the Jupyter Notebook? Okay, quite a bit less. You'll see some demonstrations later on with the interactive widgets. But just as to frame this talk, I want to quote Richard Hamming. You might have seen this quote before. The purpose of computing is insight and not numbers. Now, this was written in 1962, when you can imagine the computing power in the world at that time probably was dwarfed by maybe the computing power on your cell phone or something. Maybe that's an exaggeration. But the point is that this problem, the problem of doing computing for the sake of computing and ignoring the insight question, has only gotten worse these days with the amount of computational power we have. And it's even more important for us to concentrate on the insights we can get out of computing. And it's not just computing power that's growing drastically. We have data that's flooding just about every field. And here's some scientific fields that have data from terabytes every night and petabytes over years, et cetera. But we also have a lot of data flooding businesses as well. Think of the massive data farms, the massive data that Google or Facebook or even you experience day to day. And so with all of this data, the problem is we have much more data, we have much more computation, but the thing that hasn't scaled is we still have this little chunk of meat in our brain that needs to actually synthesize and make use of this data, and that's not growing. And so while we may have our cute little computer here, or we might have a huge supercomputer like Corey at a supercomputing center in California, we still have to interact with our brains. They're not growing very much, and that's the niche that Jupyter is trying to fill, providing a tool that makes it easy for us to interactively explore data and use computational resources, and then share that in a reproducible manner with others. IPython is, Jupyter sprang out of the IPython project. IPython started in 2001. Fernando Perez here holding the marker, and Brian Granger, one of his friends that joined shortly after. Fernando calls it his PhD procrastination project. It's what you do when you don't really want to work on your PhD. But he also decided to make it open source for very good reasons. He came from Columbia. He wanted to share his results with people around the world. And that ethos is carried through the project today. It's an open source project, and we encourage people to participate with us in the project. Of course, today it's a lot bigger. Here's a picture from our dev meeting last year. This is just a few of the people involved in the project. There's over 500 people that have been contributing, millions of people. It's kind of hard to track how many people use Jupyter, but we estimate millions of people are using it, and it's grown quite large. There's many facets to Project Jupyter. We'll cover a few of them today and talk about sort of the underlying ideas. We have many, many partnerships with many, many companies. This is partnerships that are either contributing money, people like me at Bloomberg that are contributing time, people that are working with the community to try to make the entire project, the entire stack more successful. So again, remember, Jupyter is filling this niche between the users and the computational resources and the data. And the key insight we had in Jupyter is that if we break this interaction apart and abstract these parts out, we can build a powerful system. First, we have front ends that you're actually interacting with. You're asking something, you're actually interacting with something to execute code, and you're displaying results through this front end. And you have some protocol that's communicating with the computational resource. And then you have some computational resource, which we call a kernel, running on the actual computer executing the code. And each of these is a separate, distinct sort of entity. And we've concentrated on designing a protocol that allows you to ask for execution and have a rich display of results. And many front ends we have some reference front ends, and many other people are building front ends that speak this protocol, can interact with the user to request execution, to make it very easy to iterate on execution, to display the results in a very nice way, and many, many different kernels. Now, it started with Python, but the point is, if you have a language or a computer system that speaks this protocol, you can plug right into the system, and there's sort of no loss in productivity. So the protocol is language agnostic. Well, it started with Python. There's kernels for Julia, so you can run code in all of these front ends in Julia. R, in fact, the name Jupyter pays homage to these three languages, Julia, Python, and R. But also many other languages, and people have been developing these in the open source ecosystem, and there's even commercial companies that have been developing kernels. So what this means is that if you're working with a Jupyter front end that speaks this protocol, it's very easy for you to switch between using Julia versus R versus Python versus a number of other languages. At last count, about 75 different kernels that you can run. And not just kernels, but if you have front ends that speak this protocol, then you can have many different front ends. And one particular front end that has been very popular is the Jupyter Notebook, which many of you have seen. It's a rich client that runs in the web browser, lets you intersperse explanations with mathematics, with computational code, along with rich output, including pictures and videos and 3D graphs, et cetera, as well as easy ways to interact with these computations. You drag a slider and it can rerun this code and give you the output in a blink of an eye. Now remember, this is about interacting with the computer, but that's only half the story, and maybe some people would say it's only a small fraction of the story. Really, the big picture where the rubber hits the road is interacting with the people, communicating your results to other people, and Jupyter has your back there as well. It's not just about setting up a protocol for interacting with computers. It's also about designing a format that you can share your results in. And this format enables other people to take your results and do their own analysis and interact with your data. It's sort of less of a monologue, which would be like a PDF file, and more of a discussion where you can work back and forth. You can test their ideas through this notebook format. And the nice thing about the results stored in this sort of standard structured format is that a number of front ends can read this format. So for example, we'll cover a few examples, but one of the things that we've seen sort of up to this point is if you have results with computation, a lot of times what comes out of it here in an academic journal is writing a paper, right? In the notion of reproducible research, though, this should not be the end result of your computation. This is more of an advertisement of your end result. And the end result really is all of the computations, all of the code, the entire system that you use to get to that result. And so I'd like to call out, there's a shift happening in scientific computation, a shift happening in journalism as well. BuzzFeed is a great example of publishing their research as an executable notebook that you can check their results with. A shift happening where the actual paper is just an advertisement, but here is the actual executable content of what I have. And so these are Jupyter notebooks. This is that format that I was talking about. Lets you share your results, not just as a static format, but that people can also interact with it. Of course, again, having a standardized format means there's many ways to view this. It's not just articles, but it's also entire books that people are publishing in Jupyter notebooks. You can download these books, or you can buy the books, et cetera, and actually execute these books. IBM did a project where they said, let's take the notebook format and format it more as a dashboard. So this notebook has structured data. You can tag certain cells as saying, okay, I want this to be a cell that's displayed in a dashboard, and people can interact live with these things. One of the things that we saw when people wanted to interact live is not everyone's running a Jupyter server, and so Jeremy Freeman set up a free public service to let you interact with notebooks. So this is a compute service that lets you easily pull up a notebook and run it and start working with it, even if you have nothing installed on your computer. For example, the LIGO project. The LIGO project is a project that dealt with gravitational waves, discovered the gravitational waves, one of the breakthroughs, the major breakthroughs in the last century in science. And one of the things they wanted to do is make it possible for everyone to participate in this. So they have up on their page notebooks that you can download and run in a cloud service like Microsoft Azure, or click on this link and you use Jeremy Freeman's binder. You click on the link and it pops up in your web browser, a fully executable notebook that deals with LIGO data, and you can go through the data yourself and see the results, see how they did the computations. Many companies are actually building on top of this platform to build out computational services, including Microsoft, Google, IBM, Continuum Analytics, and more. If you wanted to build your own platform, we have a tool for you there too. Jupyter Hub is a tool that we have in the project for building a multi-user system. Many academic institutions are using it to set up Jupyter deployments at the academic institution. We want to take the last few minutes and talk about the next generation of a front end for the Jupyter system, and this is JupyterLab. One of the things we realized was the notebook that we have is actually not just, the notebook application we have is not just a notebook, it's actually many different things: a file browser, a terminal, a text editor, a process manager, a cluster manager, et cetera. It's really a lot of tools that have grown and accrued that people need in their research. And so what we wanted to do is take all of those tools and put them together, put all these building blocks together into one unified interface. And this is what we call JupyterLab. It's in alpha development right now, hopefully released later this year. And Sylvain's going to give a demonstration about this. It's a collaboration of Jupyter, Bloomberg, and Continuum. And I want to call out these 4 developers in particular as major contributors to JupyterLab.
So as Jason said, when JupyterLab is the new front end for Jupyter, which collects all of these components, so notebook, console, text editor, terminal, file explorer, and process explorer. So when you launch it, this is what you see. You have a splash screen allowing you to launch each one of these activities, or you can already recognize on the left the file explorer, which is a pretty classic file explorer that allows you to copy, drag and drop files. So for example, I can move this text file into another folder and delete files, edit them, open an image. So Jupyter PNG, there you go. Obviously, since it's a new front end for Jupyter, we have a notebook component. So let's open this notebook. Just like the classic notebook, you can have rich text, executable code, images, interactive widgets. For example, here it's a data analysis notebook, and as usual. Now you can also launch multiple of these components at the same time in the same browser tab. Like here I'm launching a new terminal. And now one of the main features of JupyterLab is that we have this rich layout system that allows us to compose our workspace in a richer fashion. So with a text editor, a terminal, and a notebook at the same time, so that I have all the components of the Jupyter ecosystem running at the same time. So this, what I really wanted to emphasize, and this is something that you can already see when you open this JavaScript file, which actually is a file where we register all the components of the notebook, is that it is an extensible plugin-based system, and you can actually build your own plugin for JupyterLab. No plugin, even the notebook itself, is not really special, so you can extend this and create your own application based on this framework. Yeah, and so obviously, we have all these components for that you can launch now at the same time. Another thing that you can do is, for example, open a Markdown file and have another view of the same file edited at the same time, so that you can edit the same model and visualize the modification as you type them. So with a wig Markdown. Or similarly, if you are interested in dealing with GeoJSON data, double-clicking on a GeoJSON file allows you to either see the GeoJSON data on a map using the leaflet library, or also edit the raw text file and modify the data and see them reflected in the live map. This specific example, actually, the map example is an extension that can be installed separately And if you want to build your own extension, you can totally package it so that it can run and you can build upon the entire lab infrastructure. So I also wanted to dive a little bit in my last minute into interactive widgets. So interactive widgets are a means for you to build simple UIs in the notebook. It's more than a set of simple widgets. It's also an entire framework. So at Bloomberg, we built this library called BQplot, which is an interactive plotting library for Jupyter. This new feature, it also takes advantage of this feature of JupyterLab that allows you to tear apart the notebook, take one of the outputs, and edit it further in the notebook. So here, for example, I am pulling a figure out of the notebook and modifying it live by running cells. And since the model is duplicated between, these are two views of the same model, we actually see the changes reflected in the state of the figure. More than 2D plotting, we also have tools for 3D plottings, for 3D plotting libraries like Py3.js, and as well as a widget library for editing and drawing and building applications with maps in the Jupyter Notebook or in JupyterLab. Thanks.
Okay.
All right, you get the first question.
I was just asking about the terminal. How do you get into the terminal?
So
It was kind of it. Sorry. Yeah, like.
So we have a command palette just like Sublime Text that allows you to launch the terminal. Or you have a menu in the toolbar and a command palette where you can register commands, and the terminal component actually registered a command to launch it.
Terminal regularly, and I tell Jupyter, and then it comes up to this browser, right? And then, so then how about?
Yeah, so this is one front end for the Jupyter ecosystem. And so if you install it, you type in JupyterLab, and this web application pops up. And part of this web application is a terminal application that talks to your server and gives you a live terminal back and forth to the server. This is really powerful, actually. Some people in the supercomputing world are really excited about this as maybe being an all-encompassing interface to a supercomputer, because you have the age-old, stuff that I love, VI, et cetera, but you also have, the brand new text editors and stuff like that to work with.
Connect the ACT machine or like AWS.
Absolutely.
Yeah.
Actually, most of the cloud providers have commercial deployments of Jupyter. So Amazon included.
Does anybody else have a question?
We could talk your ear off all night
Somebody
long.
who hasn't. You'll get the next one. I want to give the mic to somebody who hasn't asked a question yet.
So as Spark starts to kind of work its tentacles into every corner of the big data ecosystem, I'm seeing a lot of interest in projects like the Apache Zeppelin project as compared to Jupyter. And I guess I'm sort of out of date on this topic, but what's kind of the state of Spark integration in Jupyter? And is there kind of a plan to increase that integration? And how do you view your relationship to Zeppelin?
There are a lot of people working on Spark and Jupyter, and I don't personally use Spark, but I understand that it's coming along quite nicely, and we're excited about making changes to the system or enabling people to write their own plugins for the system in order to enable fluid and intuitive interaction with Spark. So I would say the story is great there. Our relationship with Zeppelin's obviously another notebook-based product. I'll let them speak to their strengths, but I think you'll find that the Jupyter project has some amazing strengths and a lot of huge backing and adoption in the
So I just want to point you to the Apache Tori project, which is also an Apache Foundation project, like Zeppelin, which is the integration of Spark into Jupyter. Yeah.
You got it.
Yeah, first of all, thank you for the work on that. That's really amazing. I have a question, since you mentioned the interaction with Git and repositories. So one of the things that I found a little bit suboptimal, but I mean, obviously not your fault, is that if you want to have a diff between the new version and the old version of the notebook, basically you have a bunch of JavaScript and a bunch of HTML.
We're smiling because one of the great projects that one of the core developers that's been around Jupyter for a very long time is a notebook diffing program. So it's been released. NBDime is the name to look for, but yeah, diffing notebooks has historically been a hard thing because it's essentially diffing a structured data file, which can be hard. But the NBDime project has worked quite hard at presenting a diff in a very nice, intuitive format. Actually,
the NBDime web frontend uses the same components as JupyterLab for displaying cells and widgets and everything. So you can, it's really based on the same frontend technologies.
Related to that, there is a library that you might know, HoloViews, GeoViews, and all that, and they have a very interesting approach on making research reproducible, aka having sensible defaults where your files get saved and the formats that get saved, so that you don't mix the representation of things with the actual code content.
Great, we should talk.
Yeah.
Sure.
Thanks. I wanted to know what the difference between like the BQ-plot and the IPython widgets framework, like the cookie cutter kind of thing. What's the difference between those two? Like, and could you use BQ-plot to create your own interactive widget?
So the interactive widgets library is the foundation of this ecosystem where we have BQ-plot, Py3.js, IPyLeaflet. We also have commercial products like the Autodesk Molecular Design Toolkit and LGL View. All of these are built upon IPyWidgets. So BQ-plot is just one of them.
So IPyWidgets is the underlying foundation. BQ-plot's built on top of it, along with many other tools.
How big is a Jupyter project in terms of contributors?
Hundreds, millions of users. There's hundreds of thousands of notebooks on GitHub. So draw your own conclusions. It's hard to get specific download numbers, but we estimate single-digit millions.
A few dozen people are funded to work at work on Jupyter.
Yeah.
And so that's part of, at Bloomberg, so you guys are encouraged to participate and contribute. And
Oh yeah, I mean, we aren't supposed to do product pitches here, but that's one of the things I love about Bloomberg is I spend a lot of my time working on Jupyter. We realize the open source ecosystem is very important.
That's awesome. All right, if we don't have any other question, perfect time.
I might mention, one last thing. There's a JupyterCon conference, first one ever in New York, actually, in August. So look for information from that from O'Reilly. Those are the somewhat firm dates, August 22nd through 25th. So you can look out for that coming up in August.
Where is it going to be? In the Hamptons?
In New York. I don't know exactly where it is in New York, but somewhere here.
Okay. Very cool.
Yep.
Thank you so much. That was terrific. Thank you.